Hey guys, it's Miss Russell. I am here to help you with day 21 AMI lesson. So just like always, we're going to look at the question first to see what sort of information they want us to give them. So question number 1 says, what is the independent variable in the experiment? So remember, the independent variable is what you can change as a scientist. Number 2, what is the dependent variable? The dependent variable is where you'll be getting your data. It can either be qualitative data, which is going to be adjectives or describing, or it can be quantitative data, which means numbers. So remember, the dependent variable is something that you can count or measure. Number 3 says, based on this experiment and what you know about exercising, predict how the students' heart rates would change while they are resting after a long run. So let's take a look at the table with that question. So the table has to do with heart rates, and you count them in beats per minute. That's your unit of measure. You have 3 students. You have their heart rate at resting. That means they're sitting still, not doing anything. They're resting. Heart rate while they're walking, and heart rate while they're running. So this looks a lot like the experiment that we did with our heart rates on Valentine's Day. So you might want to keep some of those things in mind that we talked about then. Question number 4 says, what purpose does the resting heart rate serve? So would you want to go straight from walking to running? Do you want to stop in between? Why would you want to stop in between? What purpose would that serve? Number 5, what guiding or main question do you believe this experiment might be testing? So think about the CER format, the claim, evidence, and reasoning. The claim is always your answer to the main question. So if you were looking at this experiment, what would the main question be? What do you think they were trying to answer by doing this experiment? Number 6, what does the data indicate about the increased physical activity and heart rate? And on this sentence frame, I bolded the word because in blue. So I want you to tell me why you think whatever it is you think. The sentence frame says the data indicates blank. I know this because. So remember, tell me what you think the data is telling you overall, and then I want you to explain to me, excuse me, why you think the data is saying, I'm so sorry. I want you to tell me why you think the data is telling you that, or what was it about the data that led you to your belief. So let's go back up and read the passage really quick so we can get our reading in for the day. Okay, the question says, how scientists conduct experiments determines if the outcomes can be used or not. There are variables in experiments that can change in an experiment. Some will change and some will need to be kept the same. The one variable that is purposely changed to test is called the independent variable. It is graphed on the x-axis, and remember the x-axis is the one that goes from left to right. This is the variable that the scientist has control over. In other classes, this would be called the cause. Now, we've never used that term, but that's also another way that you can refer to the independent variable. Another variable that scientists have to keep track of is the dependent variable. When the independent variable is changed by the scientist, the dependent variable will respond by changing. In other classes, this is called the effect. Now again, this is not a term that we use, but just if you see it in reading other experiments, you'll know that that's the dependent variable. Scientists graph the dependent variable on the y-axis. So remember, the y-axis is from top to bottom. There are variables that need to never change, so the experiment can test one thing at a time. Those variables are to be called controlled. Hence, they are called control variables. Now, we didn't call it controlled variables. We called them constants, things that never change through the experiment, that they're used on both the control group and the experimental group. So they're the things like the flower pot size, the kind of seeds, the kind of dirt. Those are the things that stay the same all the way through. And then there's another diagram over here, the chart of similar vocabulary for experimental design. So this is sort of like a flow chart that you might want to use to help you answer some of the questions. Remember, here's cause and the effect, manipulated by the scientist. So remember, the manipulated, I've told you in blue down here that manipulated just means something that was changed. The manipulated or the cause is also called the independent variable, and it's graphed on the x-axis. On the right-hand side, the effect is the measured outcome, or what happens in the end, where you get your data from. Remember, qualitative or quantitative, and we also called it dependent variable, and that's graphed on the y-axis. So this is more practice for, we've already had problems like this in the past, so I know you'll all take your time, pay attention to what it's asking, and get the right answers. Don't get in a hurry because it seems easy. Make sure you read the questions carefully, go through the data table, and answer everything. If you need any help, remember, always reach out. We are always here to help you. Hope you're having a great day, and I'll talk to you later. Bye.